Let's say you want to solve for z. In my questions here are all with z, but it can work for any variable. How to find pz less than a is 0.2? What is the step to do for this on the GC? We will go for inverse norm. Inverse norm of area 0.2, mean SD both 0, 1. So they are really trying to say, give me this area that is 0.2, provide for me the number on the axis. So when you inverse norm, this is straightforward from last lesson, negative 0.841. Nothing special, it's just your usual inverse norm. But the special part is in the bottom cell. What if we were to change from equal into less than? How will the equation change? So you need to know how to read this part on the left. Pz less than a refers to you want the area left of a. Area left of a to be an area smaller than 0.2. Where should that be on the diagram? I put in green. Maybe here, where this is the area to the left of a. I want the green shaded area to be smaller than 0.2. So now can you tell me what is A when compared to negative 0.841? What should the inequality be? A is on the left of minus 0.841, so A should be less than. So I want you to observe here that when it was equal sign, we maintain the equal. When it's a less than, for this case, I maintain the sign. So let me just say here, I keep the sign outside. Keep the sign. The sign is maintained. But only true for this case. We will see in the center column is not the same. So center column is the area to the right of A must be 0.2, which is this area. It is 0.2. So what's the number on that axis? We have a symmetrical shape to the first one. So this is 0.841. So let's look at the question. This on the left side is now read as area right of A. Area right of A must be more than 0.2. Where should A be located? A will be located somewhere here. I want the area to be larger than 0.2. A larger area than 0.2. So what happens to A if we compare A versus 0.841? A must be on the left of 0.841, so the sign here should be less. So what happens to this sign? We are actually trying to flip, let me use this word, flip the sign outside. Okay, but there's a way to determine. It's not that confusing. I know then you are thinking then when to keep, when to flip. Okay, this is now the important part. You check whether it's a left or right area inside the probability. Inside the probability. If it's a left area, you keep the sign outside. If it is a right area or right tail, you flip the sign outside. Okay, so be very careful. There are two inequalities, one inside the probability, one outside the probability. The one inside the probability determines left or right area. I summarize a bit. Left area, always keep sign. Right area, we will flip the sign outside. You can either memorize this, which I will recommend, versus you try to draw again in the exam, maybe harder. Okay, so memorize will be better. Okay, next, center area. Unfortunately, I don't have something for you to memorize for center. We have to visualize on our own. Currently, center area here gives you an area of 0.6. So you can inverse norm for center, and you will get those two numbers on the axis. Negative A is minus 0.841. Right hand side, your A is 0.841. You get these two numbers. So the question changes. I want the center area to be more than 0.6. More than 0.6. Negative A to A should be located here so that you get a larger area. So what can we say about the numbers? Your negative A must be less than minus 0.841 or A more than 0.841. Okay, let's see these values in action in the question. So let's go to this next page, where I have modified the problem from last year's prelim. It's a 2024 prelim question. I changed to have two parts to show you that there could be different techniques that we take also. It's a straightforward short problem. You want this variable m to have the distribution here. Let's find the range of this unknown a such that this equation must hold true. This is not any of the inverse norms we know. You know inverse norm left, right, center. But this is in between two numbers and you don't know if it will be center. Center area must be really in between, in the middle. So to handle this probability, there are certain things that we should do. To do this, we should actually open up this equation. Open up means we treat it as m less than 275 minus m less than a. I don't know if you can see, it's because you can visualize as initially you want here, a to 275. It's the same as you take everything to the left of 275 minus everything to the left of a. Okay, that's why we have this equation. So to solve for the a, then you attempt to make m less than a the subject. If I move around, we will get this equation. So how to get probability m less than 275? This part will be straightforward because all values are known. This is from the GC. I have keyed normal CDF on the left, and we can get the number immediately. There are no unknown values. Okay, so this we can put in 0.64617. So this will then give me the number 0.44377. Okay, continue below. So what we are looking at here is PM less than A is less than 0.44377. At this current step, you want to do inverse norm. So the third screenshot is indicating that inverse norm M less than A is this area. So I had keyed a left area because the sign here is less than. Then we think this is left area. What will happen to the sign outside? You keep the sign. As per what we talked about just now. Left area, keep the sign outside. So after you inverse norm, we should get A less than that inverse norm value, 270.87. And this will be the range of my A values. So what's the difference with part 2? Part 2 mentions now that A is integer. You still want to solve the same problem, find the range of A. Whenever it's an integer unknown, what do? You go for graphing calculator with a table. This is for integers. Not to be confused, just now you use a graph because graph is for non-integers. Table is for integers that are unknown. So what do we key? You want to key this equation in straight away. That means for the lower set of screenshots, your y1 is probability of this, where A, you set it to be the unknown x. Y2, sorry, don't need y2. We move all to one side. We move the entire equation to one side. So you want to check when is this equation more than 0. Okay, instead of drawing y1, y2, we move all to one side, check when is the equation larger than 0, and you go for a table again. So I've keyed the equation here, lower is your x, the rest are all known. And we check when is the last time that it is more than 0. It's at 270. Okay, so we can just put, therefore, that from the graphing calculator, my A will be less than or equals to 270, and A is an integer value. Okay, so usually with a graph or a table, the answer is just one line because after that you use the GC. So if you want to, can use this, but be careful. Integer is table, non-integer is graph.